Hey everyone, this is Jane. And welcome back to my channel Electrons. So, as we are beginning to explore the world of electricity and electronics, and it is much important to start by understanding the basics of voltage, current, and resistance. These are the three basic building blocks required to manipulate and utilize electricity. But in today's video we will be just looking at voltage. We will discuss other fundamentals later on in next videos. So let's continue with our video. But before starting this video, please make sure to subscribe our channel and don't forget to press the bell icon down there as it helps maintaining the flow. After watching this video you will get to know what is voltage, how does it works, how to measure voltage and much more. So, what is voltage? At first, these concepts can be difficult to understand for anyone because we cannot see them. One cannot see with the naked eye the energy flowing through a wire or the voltage of a battery sitting on a table. So for instance I will try to demonstrate you the basic concept through real-life examples. Now consider this water tank at a certain height above the ground. At the bottom of this tank there is a hose. Voltage or potential difference can be compared to water stored in a tank. The larger the tank, and the greater its height and thus its potential velocity, the greater the water's capacity to create an impact when a valve is opened and the water-like electrons can flow. This pressure at the end of the hose can represent voltage. The water in the tank represents charge. The more water in the tank, the higher the charge, the more pressure is measured at the end of the hose. We can think of this tank as a battery, a place where we store a certain amount of energy and then release it. If we drain our tank a certain amount, the pressure created at the end of the hose goes down. We can think of this as decreasing voltage, like when a flashlight gets dimmer as the battery runs down. There is also a decrease in the amount of charge like water that will flow through the hose. Less pressure means less voltage in the battery. In electronics, potential difference is commonly referred to as voltage, with the symbol V. It also refers to the possibility of doing work, as electrons move more freely in a conductor. But some kind of force has to pull the electrons from one place to another. This attraction or repulsion force between positive and negative charges is an electromotive force. So remember, though that voltage is the potential difference between 2 points, and those two terminals are necessary for a potential difference to exist. A potential difference cannot exist at only one point. Potential difference might be better defined as the potential energy difference between 2 points in a circuit. Voltage is defined as energy per unit of charge and is expressed as voltage equals to charge into energy. Here V is voltage in volts, W is energy in joules, and Q is charge in coulombs. To illustrate voltage in another way, let's say in this circuit that you have a wire as a conductor, and we attach one of its ends to the positive terminal of a battery and the other end of the wire to the negative terminal of the battery. Electrons then flow through the wire from the negative to the positive terminal of the battery. The electrons moving through the wire pass through the wire filament in the light bulb, causing the bulb to light up. Here voltage is the cause to light up the bulb. If this circuit is opened by disconnecting the bulb, now no current can flow because there is no closed path. Still, the battery has its potential difference. If you measure across the two terminals, the voltmeter will read 1.5 volts. This is like a battery sitting on a store shelf. Even though the battery is not producing current in a circuit, it still has a voltage output between its two terminals. This brings us to a very important conclusion. Voltage can exist even though without a closed-path circuit. We can consider this circuit as a means whereby the energy of the voltage source is carried by the current through the filament of the bulb, where the electric energy is used in producing heat energy. On this basis, the battery is the source in the circuit, since its voltage output represents the potential energy to be used. The part of the circuit connected to the voltage source is the load resistance, since it determines how much work the source will supply. In this case, the bulb's filament is the load resistance on the battery. Now let's see how the voltage source maintains its potential. Here as current flows in a circuit, electrons leave the negative terminal of the battery, and the same numbers of free electrons in the conductor are returned to the positive terminal. As electrons are lost from the negative charge and gained by the positive charge, the two charges tend to neutralize each other. This chemical action inside the battery, however, continuously separates electrons and protons to maintain the potential difference across the circuit. Now let's see how volts is actually different from voltage. as voltage is the measure and the volt unit of potential difference is named after Alessandro Volta. Fundamentally, the amount of difference expressed in volts determines how much potential energy exists to move electrons from one specific point to another. The quantity identifies how much work, potentially, can be done through the circuit. By definition, the potential difference between those 2 points is 1 volt when the unit of work or energy is the joule. 1 joule is the same amount of work or energy. Therefore, we can say that the potential difference between 2 points is 1 volt when 1 joule of energy is expended in moving 1 coulomb of charge between those 2 points. Here we consider the 2.2 volts lead-acid cell. Its output of 2.2 volts means that this is the amount of potential difference between the 2 terminals. The lead-acid cell, then, is a voltage source or a source of electromotive force. Voltage is either alternating current AC voltage or direct current DC voltage. Alternating current voltage, represented on a digital multimeter by this, and direct current voltage by this. More common than DC voltage. Utilities deliver AC voltage to homes and businesses where the majority of devices use AC voltage. Primary voltage supplies vary by nation. In the United States, for example, it's 120 volts. Some household devices, such as TVs and computers, utilize DC voltage power. They use rectifiers, such as that chunky block in a laptop computer's cord, to convert AC voltage and current to DC. Now, how voltage is actually generated. Voltage can be generated by means other than rubbing certain types of materials against each other. Chemical reactions, radiant energy, and the influence of magnetism on conductors are a few ways in which voltage may be produced. Respective examples of these 3 sources of voltage are batteries, solar cells, and generators, such as the alternator unit under the hood of your automobile. For now, we won't go into detail as to how each of these voltage sources works. More important is that we understand how voltage sources can be applied to create charge flow in an electric circuit. Now, how to measure voltage. A typical digital multimeter DMM is used measuring the voltage across the terminals of a battery. To measure any voltage, the meter leads are connected directly across the 2 points where the potential difference or voltage exists. For DC voltages, the red lead of the meter is normally connected to the positive side of the potential difference, whereas the black lead is normally connected to the negative side. When measuring an alternating AC voltage, the orientation of the meter leads does not matter, since the voltage periodically reverses polarity anyway. If you want to measure the voltage drop in series, just connect the 2 leads of a voltmeter across the resistor. Lastly, why measuring voltage is useful. Engineers approach most troubleshooting situations knowing how a circuit should customarily perform. Circuits are used to deliver energy to a load, from a small device to a household appliance to an industrial motor. Loads often carry a nameplate that identifies their standard electrical reference values, including voltage. In place of a nameplate, some manufacturers provide a detailed schematic, technical diagram of a load's circuitry. Manuals may include standard values. These numbers tell engineers what readings to expect when a load is operating normally. A reading on a digital multimeter can objectively identify deviations from the norm. Even so, the engineer must use knowledge and experience to determine the factors causing such variances. That's all for today, and I hope that you find this video useful as well. So if you haven't subscribed yet, make sure to do it so and give this video a thumbs up as well. See you in the next video. Thank you.